So we're going to jump into the data viz world, more specifically dashboards, so data science, web applications. So my talk is tips for writing and maintaining Dash.jl applications. Okay, so first of all, wait, put this in full screen actually. Okay, this looks better. Okay, it's a big screen. Okay, so what is Dash.jl? So Dash.jl, it's a Julia package. It's the Julia version of Dash from Plotly. So Plotly is a company. Dash is a popular data science web application framework in Python. Dash.jl is the Julia version of that framework. It's open source. In the Julia world, I think the closest framework is Tétreault, which is based on Genie. I say similar because they're both fairly high level and fairly tailor-made towards data science applications. And then if some of you know R, it's kind of like Shiny, which has been around for a while now. Okay, so let's get a feel for who showed up. This was a weird block of kind of, left and right talks. So I don't know who showed up to mine. So who has ever used Dash.jl before? So just a quick show of hands. Okay, not too bad. More than I expected. Who's ever used the Python version of Dash before? Quick show of hands. So less people. Okay, that's interesting. Okay. Who has ever used a Plotly plotting library before? Okay, so a lot of people. Okay, good. So those of you that have never used Dash.jl before, don't worry, there's going to be an overview section. And then for you, those of you that have used Dash.jl before, well, we're going to get into some more interesting stuff in the later slides. So I'm gonna, when it comes to choosing a framework, especially when it comes to web applications, a lot of it comes down to personal taste. And I kind of don't want to get into that today, but I still want to make an argument for using Dash.jl. So this is going to be my argument. So why use it? First off, most of the logic is done in JavaScript, using libraries that Dash.jl shares with the Python version of Dash. What that implies is that Dash.jl doesn't actually have that much Julia code. I mean, that's still still 3,000 lines if you count them, but for the amount of stuff that you can do in Dash.jl, that's not a whole lot. And like I said, so it's based on the same libraries that the Python version uses. And then if you go on PyPy and you look at the Python version of Dash, it has over 1 million downloads per month. That's something that any Julia library would have a hard time doing. So I'm going to go ahead and make this claim, saying that Dash.jl is more robust than the other web UI libraries out there in Julia. This is, of course, a debatable claim, so don't shoot me. Yeah, okay. Next, so why am I giving this talk? So I'm currently working at R2, engineering consultants in the chlorine production industry. So it's the electrolysis of brine. I won't get into the details here, but I guess what I can say is I'm split my time between doing data science and developing data science web apps in Dash.jl. So we're based in Montreal. That's in Canada, if you don't know. Yeah, let me show you a few screenshots of the apps we have internally at R2. So this is all Dash.jl. Some of the stuff you can do. Another screenshot. Okay, so next, there's more reasons why I'm here. So previously I worked for Plotly. Remember, that's the company behind Dash. Full disclosure, so I guess some of you might say that's another good reason for using Dash if you worked for Plotly before. And then last fall, I've met with my former boss, and I told him I was using Dash.jl for work. and he's a nice guy, and he went ahead and gave me write rights to the repo. And then since then, I've made 2 Dash.jl releases. Last one coming a few weeks ago. And then what I'd like to, what I wish out of this talk would be to have more people use Dash.jl, of course. Have more people willing to contribute to the Dash.jl repo. And then if we could get together and maybe start building a new package that would wrap around what's already available in Dash.jl, something that would be more experimental, more Julian. That would be cool also. Cool. All right. So outline. That was the introduction. Next, I'm going to do a quick overview of Dash.jl. After that, I'll show you how to add a simple feature in Dash.jl just to get a feeling for how the thing scales. And then after that, I'll discuss how to make Dash.jl feel a bit more like Julia. So this is a Julia code, Dash.jl, 25 lines. Already gives you an interactive data science web app. And let me go ahead and show you how that looks. So this is an iframe pointing to a server that I'm running on my laptop. So it's fully interactive. And then this is just, it's kind of hard to do. I should have brought a mouse. But if I go ahead and select a data file, this is going to create a Gantt chart. And then let's say you have multiple data files, you go ahead and select the other one. And then, of course, this is a Plotly graph. So if you hover over it, you get the exact values. This is the sort of graph we use a lot at R2. So in industrial settings, the start of a bar could signal the start of an anomaly or fault. Say your temperature is too high at your plant. And then the end of the bar would be where that condition ends. So then with hover labels, it's kind of easy to tell exactly when something wrong started and ended. All right, cool, let me get started. Let me keep going. So I'm gonna go step by step just to show you how we build a Dash app. So you start with using Dash, then you instantiate a Dash app type with this lowercase dash wrapper. So Dash doesn't ship with CSS by default, so you'll see this external style sheet a lot in the tutorials, but you could have any CSS. Then this app, we'll use it to run an HTTP server. But before we do so, we need to set up a layout. So this is just a combination of HTML components and also more evolved components. So this DCC means Dash core components. And this is exported from the Dash module. So here you see we have a dropdown and a graph like we just saw previously. Please notice the IDs set as keyword arguments here. So we're going to use those IDs to add interactivity. So interactivity here, I mean something happens in the front end, so a user clicks or selects something in the dropdown. We're going to use this new value coming from the dropdown to update a component. And in this case, it's our graph. Dash calls them callbacks. And so they work like so. So you need to set an input, which works like a trigger. So anytime the dropdown value changes, this function is going to get called. And then the return value of that function will update the figure property of the graph. And then we're defining this as a do function. So fname will be the file name coming from the dropdown. And then there's a bit of logic. So when you start the app, fname isn't set. It's set to nothing. So you need to handle that case. And that happens a lot. I'll talk more about this later. And then, so this make GAN function, I kind of cheated. So this app is more than 25 lines. This is how the make GAN function looks. This is one way to do it. It's one way to make a GAN chart. Plotly doesn't have a way to make a GAN chart natively, so you need to work around the bar type. So this is one way to do it. And so Plotly graphs are essentially just a big JSON. So you can use any data types that serializes to a JSON. In Julia, I like name tuples a lot, but you could use a dictionary or wrapper libraries. I think it's called Plotly.js if you want. But a plain name tuple works, and I find it really nice, especially with the implied keyword syntax. So you can define y base x on separate lines and then just shove them into a name tuple like this. I find it kind of nice. So what happens after that? So Dash will serialize that into a JSON using JSON3.jl. And then this will, then the front end will get that JSON and then render the graph in JavaScript. This is what happens behind the scenes. Okay, so I'm going to show some Python code at JuliaCon. But again, this might be controversial, but this could be helpful too. So this is the exact same map that I showed you. It could be generated using this Python code. And if you look at it closely, or if you paid attention, like it's very similar to the Julia code. So that's good because, again, there's a lot of Python Dash users out there. There's a lot of examples online. So if you search for something and you see Python code, after a bit of practice, you could easily translate it to Julia. And most of the time it will just work. I mean, it's not, not all features will work, but most of the features will work. So we get a lot of documentation for free just because code just looks pretty much the same. Next tip. So if you're looking for something, some interactivity, and you don't know the property names of your components that you want to update, the Julia REPL is one nice way to get that information. So next, we're going to add a feature. We're going to use the click data coming from DCC graph component. And yeah, so the Dash REPL is a nice place to get that sort of information. Okay, so next 15, okay. So yeah, so like I said, we're going to add a feature, see how this thing scales. So what we want to do, we want to handle the click data coming from the graph. We're going to add some HTML to the layout, and then we're going to add another callback. Here, this has a different, not yet. Okay, so this callback has another little dash type in there called a state. So a state will not trigger the callback. It's just the value that your callback can use. But the callback isn't going to get triggered whenever that thing changes. In other words, this callback gets triggered whenever we click on the graph. And in that callback function, we'll also check and use the file name we selected in the dropdown. And to start, we're just going to make a string out of it and see what kind of result we get. We're just building this app interactive step by step. So if I, again, pretty tricky to do. select this B type, and then the click data will show up here. Okay, so you get some information corresponding to the bar we just selected. We just clicked on, sorry. And then if you click on a few different bars, the thing changes as expected. So now what we like to do, we like to make something more interesting out of this click data. So let's say instead of just outputting a string, we use this click data to generate a new graph that would be the zoomed in version of the graph above. So in Plotly lingo, that would be changing the x-axis range and creating a new graph. So let's go ahead and do that. Okay, so again, we're going to start with adding some HTML. This is going to be our container div. Then we're going to add a new callback. And notice here, I'm going to use a different syntax for the callback. So here I'm going to pass a name function instead of using a do block. You'll see why. Another thing, I'm going to update two things. So there's two update types. And then this update close-up look like this. So there's a lot of boilerplate here. But the cool part with Julia, you could use multiple dispatch to kind of discard invalid values. So we know that a valid file name will be an abstract string, and then click data, we don't want to use blank click data. We want to use click data that's a JSON3 object, which is similar to a plain Julia dictionary. But this is the type that Dash returns. So we use two methods. It's a nice way to do validation at a really high level. So this is just boilerplate. So from the click data object, we'll try to pick our way to get a new x-axis range. Will look like this. And then with this new axis range, we'll create a new figure object, a new figure name tuple. And then using name tuple as argument splatting, it's kind of nice, I think. So name tuples are immutable, so you can't just mutate the new value in. You need to create a new one, but all the Julia's sugar makes it kind of nice. And then once we're done, we're going to output a new Dash component here, a graph. So callbacks can output components, which is nice. And then I'll show you how this looks. Okay, so we're same graph, and then if I click on it, I get a close-up graph. So it's the bar I clicked on plus or minus 1 day, which can be convenient to view some sort of fault in more detail. Okay. Now how much time do I have left? Okay, cool. Okay, so now we have our app. It's pretty good. But like I said, there's a bit of boilerplate involved, and we'll try to write it in a better way, in a more Julian way. So here, this is just highlighting the boilerplate that I'm calling the validation that we see often in callbacks. Okay. So one way to do it would be to come up with new types. This already feels pretty Julian. So I'm going to create a new abstract callback value. So callback value would be, you can think of it as the argument to our callback functions. And then the concrete types will be just wrapper structs around the values that we're going to use. So here in our app, we're using the file name. So this is fname. And we're using the point that we clicked on. Sorry, the bar. This could be, click bar would be a better name, actually. And then with these type, we can create, we create a function called from dash. So dash will get you something that comes from JSON. And then what we can do here is have a wrapper function that will instantiate our new callback value types when that value coming from a dash interaction is valid, and output nothing if it's not. And that way we'll be able to do a multiple dispatch based on our new types or the nothing type. And if we go ahead and plug this into our app, so this is the update close-up, looking a lot easier to read, more maintainable, more scalable. So here we're, instead of dispatching on JSON3 objects and having to dig our way down to the values we want, we're just dispatching on click point and fname. We still have the the fallback method. And then our callback looks like this. So I'm adding back a do function. You'll see why very soon. So here I'm just using from dash and then calling updates close up with our new types. And then it's pretty easy to go from this little piece here with the from dash method to a new function called add callback that will call from dash explicitly. And then we could pass in our new types in the input and the state definition, like this here. And so this way we can take in values coming in from dash that are JSON3, that are read using JSON3 into our new defined types. And then we could use multiple dispatch to simplify the logic. And I think I'm going to end here. All right, so any questions? Yeah.
As far as I understand, everything you said requires the app server to be running to deliver the data. Is there a way to save site state to a static file that doesn't require a server?
Is there a way? Okay, so the question is, if I got it correctly. So yeah, the demos I've used. So is there a way to use Dash without a server? Is that correct? Well, I guess you could. Short answer, no. You need a server running somewhere. In that particular example with the dropdown, you could have the data in the front end to start, and then have the dropdown select from data that's just in the front end, as opposed to making a request and then getting the data back. But yeah, you need a server running. Yeah, it's kind of a, you can think of it as a wrapper around HTTP, HTTP.jl. Very high level wrapper. Yeah.
But once now sharing publicly, like GitHub.io, and so it wouldn't have a server there. Do you have a recommendation? How do you go to that? Is it static?
So your dropdown would be a list of URLs instead. Yeah, good question. I mean, I guess you could, but I guess you would also run into cross-origin problems sometimes. Yeah, I can't answer for sure, sorry. But good question, though. Yep.
Julia structs that already have a show method for text HTML.
Say the last part again, sorry?
So if you define a struct and you can write a show method or like the line type text HTML, is there a way to take advantage of that, like get that to display in Dash?
Okay, so the question is there a way to reuse structs in Julia to have a a show HTML method.
So, for example, there's the package that is there a way to like? Yeah. Is there a way? It's like a templating language for HTML. Is there a way to use something like HyperScript to create a bunch of HTML and then have that show up on a Dash page?
Well, not at a low level. I mean, there's a way to create your own components in Dash. But yeah, it's essentially you need to build a React.js component first, and then get that into there's a way to get that into a Julia package. So plain templating, I guess no. I guess you need a bit more for Dash to work. Yep.
So you have this callback bang method, right? That has you have multiple methods for that. Is that right? Because you have different input, output, and state arguments. Is that right?
Okay, so the question is, does the callback bang function have different methods? I think it's not. I think it's just one big argument splat. But
what's the relation between the inputs and the outputs you expect from your callback function? Is it always the same click and frame or something, wasn't it?
Okay, so based on different output and input combinations, are we expecting a different behavior? Is that it?
From the callback, the actual callback function.
Right. So what Dash does internally, it essentially serializes that into a JSON and then passes it to the front end. So whatever output you have behind the scenes, you'll get a JSON. And then the front end will handle that in JavaScript and then get it to render properly. So yeah, there's you could have one output or multiple outputs, so that changes a little bit what you get out of a callback, but that's about it. I don't know if that answered your question, but we could talk about it more. Cool.